name's Eric. Today we're doing a tutorial on how to use this VLS 3.60. We have a work in progress right now going on, but while that's going on, I'm going to just give you guys some specs on this thing. The table can handle up to a 24 by 12 piece. Actually, I shouldn't say that. That's the table size. But what you have in there can exceed it by about 1.5 inches each way, up to 4 inches deep. Your part can weigh a maximum of 20 pounds, and in order to use this thing, you need an operating system. It is preferred to have a PC with Windows Vista, or Windows 7. This laser can go up from 10 to 50 watts. It uses a 110 or 240 volt power source. Now, and to correctly use this, if you're using it all the time, you should have a ventilating system. And this one has one built into the back of it with a 3-inch duct. And it comes with a blower motor that has 250 CFM cubic feet per minute. That's pretty much all the specifications associated with this thing. It weighs about 100 pounds. This model can vary a little bit. On average, they're about $20,000.
I'm Dave Sturgill, and I'm a technology education major. Like Eric talked about earlier, these are common lasers. One of the principles of career and technology education is that students should learn on machines that are industry standard, that are common pieces of equipment they'll find in the workplace. That's definitely true for the VLS laser. It can be found in many trophy shops and artist studios, also machine shops throughout the world. So this is an excellent piece of equipment that has a lot of different capabilities to burn, engrave, to cut glass, metal, plexiglass, wood, ceramics, many different kinds of materials.
The laser will appear as a normal printer that you will access from inside whatever software program you're using. So, for example, today I'm in Rhino. I'm just going to go up to the File, Print menu, and I have the option, if you can see where my mouse is, VLS 3.60. This brings us to an important point. The VLS interprets different colors to mean different commands. In this case, if you look where all the red lines are, that's going to be cut through. Where the blue is, that's going to be burn that image onto the surface of the wood. So that it's important, no matter what program you're using, whether it's Rhino or AutoCAD, SolidWorks, or even Microsoft Word, that you set up different colors beforehand with the intention of having them cut through, cut to a certain distance, burn an image, burn a vector image, burn a raster file. All these things require a little bit of planning before you start.
So now the laser is cutting through the material actually, and this is on your drawing, this is the red. It has to be red in order for it to cut all the way through. It just got done doing all the raster, which is the side-to-side motion engraving all these circles, and that's blue. After it's done cutting this out completely, it'll go back and do a vector and clean up the edges of everything. It'll trace the outside perimeter of those circles to give you a real clean, crisp edge on everything. This red is set for about 95 to 100%, so it cuts all the way through the material. Now it's coming out and doing the outside perimeter. This is Dave's trim piece for his smart mirror project. He's going to be presenting at the 2017 WITEA conference. It'll look first class. So now the laser's got done cutting it all out with the red, and it's going back and doing a vector cut on the perimeter of all these circles. And it's not cutting through, it's just engraving. This will allow for a very clean edge on everything. Really make it stand out and look good. It traces the perimeter using the geometry drawn in your CAD program versus the raster, which just goes side to side, doing more of a pixelated type engraving. You can tell the difference pretty clearly. So the laser got done cutting this out. We'll go ahead and open up the lid and take it out. It did all the raster stuff first, came through and cut everything out, and then did the vector at the end. And it looks like it did go all the way through. Sometimes it doesn't. And you have a finished piece. Looks pretty good. Next, Dave will do his plexiglass, and that'll complete his project.
Eric is going to lay out some examples of what the VersaLaser can do. It's capable of fine precision cutting. In fact, at Wahluke High School, with just a few donated materials and a VersaLaser, they're able to produce all the trophies that the high school, that all 5 schools in the district use, just with the VersaLaser. It can be used for all kinds of engraving, cutting. As you can see, a fully working gear system was cut and no additional finish work was needed. This is an excellent example for teaching STEM principles, and even a science teacher can use it.
So we're going to look now at our second example piece that we're going to cut, this time out of plexiglass. And I want us to follow the process all the way through from the software program to the finished print. I've drawn what I want in Rhino, and again, a quick reminder, my red layer is things that are going to cut all the way through the plexiglass, and my blue are things that are just lines that are going to be etched into the glass. So once I have everything to my satisfaction, remember, the laser cutter just appears like any other printer, so I go File, Print. I make sure that VersaLaser 3.60 is selected, and I'm just going to do a little quick tour here. I make sure my scale is 1:1. I make sure that I'm printing my extents, just one copy. Now I'm going to go into Properties, and this is where we see we'll open up the VersaLaser software. I really want to point out that there are 2 different tabs here. One is the materials database and 2 is for manual control. Because we're dealing with a sheet of acrylic plexiglass here, we're going to go into the materials database. We're going to go to plastic, and then acrylic, And if you have any questions, you can usually look on the material and there will be a label of some sort, which is definitely the case here. Now the really important thing, and this is something that I pick up off the label, the paper label that's on the plexiglass, is this is extruded acrylic sheet. There's a large difference in settings between extruded and cast acrylic, so this is absolutely critical to get right. I've used my calipers and I've gotten the thickness, which is 185 thousandths of an inch. So I am ready to apply those settings. There's my thickness there, there's my extruded acrylic, and I say apply. Now we'll just go over to manual control, this second tab here, and we'll take a look. My red is vector, it's 100% power at 2.3% speed, 1,000 pulses per inch, and our thickness is 185 thousandths of an inch. That's going to cut through all of the plexiglass. I take a look at my blue. Again, we're just doing 76.9, speed 100%, pulses per inch 1,000. So that's going to give us a nice sharp line, we hope. I could make any changes here by sliding the buttons, but I know that in this case the materials database pretty much has it right. So if I were to change these things, I would hit set and then apply. But for this case, I'm just going to say OK. And now I am ready to say print. Once that happens, the print dialog from inside Rhino disappears, and I want you to look here in the lower right hand corner of the screen. I'm moving my mouse down there, and I'm clicking on this little red VersaLaser icon. This brings up the control panel here. What I would want to do is I could move things over, and I am actually going to want to do that. I could take this grip and I could move everything over. I want to make sure. I can also use my arrows. So everything looks good, and I can double check the position of the laser there. And I'm going to say print.
So this is the beginning of the print job on the piece of acrylic sheet. As you can see right now, it's actually cutting through the plexiglass. Got some of the detail of the little notches that I carved out just to show the little half circles, just to show the capability of the printer itself. And we'll go ahead and pause that now until we get into our hatching. Move over to our etching. You can see that. Finished with the acrylic. We're gonna pull it out. So later I'll be able to peel the protective backing off, and that'll be a clear piece of cut plexiglass with those decorative etched lines on it. I'm really happy with the way it turned out.